Hi, my name is Brenda. Today I will be talking about DNA replication. What you see right here is a DNA strand going from 5' end to 3' end and then 3' end to 5' end. First, we are going to be starting with our topoisomerase, which will come through this DNA strand and it'll essentially strand it out so that helicase can come through and open the strand up like so, and then calling for SSBP, which will hold this strand apart, creating this to be the lagging strand and this strand to be the leading strand. Then primase will come here and create a primer so that DNA polymerase 3 can come here and start the coding process, which will create the replicated DNA strand. The T nucleotide will code for the A nucleotide, G will code for C, A will code for T, and it will do this throughout this whole process, or this strand of DNA. And as DNA polymerase 3 passes this strand that has the SSBP, it'll kick it out of the way because now we have this new strand of DNA holding it apart. Alright, so I have just created my new strand of DNA, and after that is done, the DNA ligase will come in here and kick out the primer, and this ligase will bind the strand together with each segment that has been created, and it will leave out of here, making this the lagging strand and this will remain the leading strand. Go!
Transcription is the first step that takes place in the central dogma of biology, where information from a gene is used to make a protein. The enzyme involved in transcription is RNA polymerase, which takes single-stranded DNA and makes a complementary strand in the 5' to 3' direction. There are 3 stages that occur during transcription. The first step is called initiation, where transcription factors tell RNA polymerase where to bind to the sequence in DNA called the promoter. And once bound, RNA polymerase separates the 2 copies of DNA strands. The second step is elongation. As RNA polymerase reads the template strand, the RNA molecule is made out of nucleotides. The RNA transcript carries the same information to the non-template strand, which contains the base uracil. Finally, the third step is termination. The sequence is signaled to terminate once transcription is complete. From there, the transcript is released from the RNA polymerase, where it continues on to translation.
Hi, I'm Erin and I'm going to go over the process of translation. So what we have going on here is we have our mRNA strand, we have a ribosome, and it's split into 2 pieces. You have your small ribosomal subunit and your large ribosomal subunit. And then you have your tRNA or your anticodons with amino acids. So your mRNA strand has to be bonded to your small ribosomal subunit to start the process. So this guy is going to come up, and it always starts with AUG. So we have AUG here. And then your large ribosomal subunit will come down. And your mRNA can't do it alone, so they need an anticodon and an amino acid. So your anticodon will come down with amino acid, methionine. And A always pairs with U always pairs with A, and then G always pairs with C. So those line up, and then we'll just move this guy along. These come in, and your anticodon comes in with your amino acid. You have your things that line up. And once you go to the P site, your amino acid breaks off, and these guys keep going to the A site. Then your anticodon comes in, with the amino acid. And then this comes out and these two form a peptide bond. And then once you hit your A site, your anticodon is going to leave. Then your mRNA is just going to keep going, doing its thing, stay together. Then this guy will leave. This will form a peptide bond again. And then your anticodon will leave. So you need your anticodon here. And once you have your anticodon, this is a stop codon. A stop codon tells the ribosome to split. So these guys come down here, these come up here, and then your anticodon is over there. So your ribosome splits, and then it's used over and over in the cell, and it's looking for the mRNA strand, and your mRNA strand is looking for your ribosome, so they're recycled. And then your anticodons are looking for your amino acids. And then here you have your proteins, and then they can do whatever they need to do in the cell.